And so here's a hint on this one. I don't think I did this one last week. I'm going to use the integral test to determine if this series, as n goes from 1 to infinity, of 1 over n squared converges or diverges. And so what I'll do for this is the sequence a sub n is 1 over n squared. Now that's different from the series, but there's my little sequence. I'm going to model this sequence with a function. Model this sequence with f of x is 1 over x squared, where when x is an integer, then this function matches that sequence perfectly. So this is what we're doing when we use the integral test. And to use the integral test, I have to have some certain conditions met, that the function must be continuous, positive, and decreasing. So I will ask that question: is f of x continuous, positive, and decreasing on the interval from 1 to infinity? I'll use a bracket there, but I think I could use parentheses next to 1. I'll put my question mark. Okay, so there's if that's true, I can try the integral test. Well, continuous. Let's see. Here's my function. Where is f discontinuous?
0.
At 0. And 0's not on this interval. So, okay, continuous, we got it. And then positive. If I plug in numbers 1 and bigger, and I square that number, it'll stay positive. 1 over a positive number, it's positive. Now, is it decreasing? On some of the problems, it's kind of obvious that it's decreasing. And this one, is it obvious that it's decreasing?
Yeah.
Yes. The denominator is getting bigger and bigger and bigger, meaning that the whole fraction is getting closer and closer and closer to 0. So it's decreasing. So we can try the integral test. So let's find the integral from 1 to infinity of 1 over x squared dx. So this is actually a problem from section 7.8, and I'll write it like this. So the integral from 1 to infinity of 1 over x squared dx is the limit. I'll use a t, that's what the book used in 7.8. The limit as t approaches infinity of the integral from 1 to t, 1 over x squared dx. Now that 1 over x squared, I have to at least think this in my head if I don't write it, but I prefer to write this. 1 over x squared, that's x to the minus 2. Because then I can say antiderivative, add 1 to the negative 2, and I will get negative 1 for the exponent. So, in fact, it's going to be negative, because it's going to be x to the negative 1 over negative 1. And that could be negative 1 over x. So the limit as t approaches infinity of negative 1 over x, and I'm going from 1 to t. We'll plug in the t and the 1. So that's going to be the limit as t approaches infinity from negative 1 over t minus negative 1 over 1. As t goes to infinity, negative 1 over t goes to 0. So this is 0 plus 1, and that's 1. So the integral converges. That means the series does what? Also converges. Since the integral from 1 to infinity of 1 over x squared dx converges, then the series, as n goes from 1 to infinity of 1 over, that's an n squared, also converges.